Okay, we are starting today's class, that is quality control in clinical biochemistry laboratory. Basically, quality control is present in various laboratory, but we will understand in clinical biochemistry aspect, okay, how the quality control is happening, as well as what is quality control, what are the objective of quality control. We will learn lots of things gradually. Just stay tuned with me. Just see here. Basically, quality control is an essential procedure to maintaining the accuracy, to maintaining the precision, to maintaining the reliability of the laboratory result. Getting my point? First thing, it's basically enhance the accuracy, precision, and reliability. Okay? And the fundamental purpose of quality control is to identify, means you have to identify it. After that, you have to minimize and you have to rectify the error. Firstly, you have to identify what's error basically going on into your laboratory. Secondly, you have to minimize it or you have to prevent the particular error. And thirdly, you have to rectify it. It means you have to fix the particular error. Getting my point? That's basically the core as well as the fundamental things of quality control. Okay, see, now we are coming to the objective section as well as the objective of quality control. What is the objective? We need to understand, right? What is the objective? See, objective of quality control. Getting my point? See, key objective of the quality control is basically establishing the confidence in the laboratory result. You have to establish the quality control as well as you have to establish a confidence that your result is too much accurate as well as your result is reliable for the patient. You have to establish the confidence into the laboratory result. Getting my point? Secondly, you have to minimizing the error. Whenever you are minimizing the error, your accuracy of this particular result should be increases. Okay. Thirdly, validating the laboratory procedure and method. There have the particular method in various laboratory, right? So that you have to check this kinds of methodology, is procedure, is it right or wrong, as well as if any kinds of mistake are done in this kinds of methodology, you have to rectify it. Okay, after that, promoting the standardization and harmonization. Standardization means whenever you are providing as well as whenever you are doing the test in accurate manner, then you have to promote the standardization. That's all things are very basic and we will gradually involve into the core part. Okay, but that is a little bit introduction, otherwise you will not able to understand what is quality control and how it's happening. Okay, that is the basic things we need to understand. After that, we will move to the core section. Okay, after that, ensuring with the regularity as well as accreditation requirements. What are the accreditation? What are the requirements of this particular accreditation body, like NABL, like ISO, like another type of accreditation body? What are the discipline? What are their requirements? So that you have to fulfill their requirements, fulfill their regularity. Getting my point? So that's all are the objective, or we can say that purpose of quality control. Say me, up to this much, any problem?
No, sir.
Okay, anyone facing any problem in the objective section? I think everyone
No,
understood.
sir.
Okay,
No, sir.
okay, fine. Malik, you are first time attending my class?
जी सर,
Okay,
फर्स्ट टाइम।
आप कहाँ से हो?
सिद्धार्थ नगर, उत्तर प्रदेश।
उत्तर प्रदेश से। वेरी गुड, कोई दिक्कत तो नहीं हो रहा है?
नहीं, कोई दिक्कत नहीं।
इंग्लिश में कंफर्टेबल हो ना?
जी।
बहुत कंफर्टेबल। वेरी गुड, ठीक है। Okay, now we are understanding the fundamental concept. Okay, now we are understanding the fundamental concept of quality control. And the previous section we have discussed about the very much introduction, right? Now we are going to the fundamental section. What's really required? to running a quality control? See, firstly, control materials is required, and I am just changing this pen because this pen is looking like same. Okay, we have to change it. Okay, see, control materials we need to understand. See, third thing, we need to understand the types of error. You will understand it gradually. See, firstly, types of control materials. Lymphocyte or freeze-dried materials. There have some commercially purchased quality control materials which you have to freeze, as well as which you have to dry in a freezed way. That is also one type of materials of quality control. Secondly, liquid serum pool stabilize the liquid control, that is also used. Okay, because you have to collect them some quality serum and you have to create it in a pool way. Okay, and whenever the quality control is required, then you might use these kinds of serum. That is quality serum pool. Okay, after that, frozen patient specimen. Frozen patient specimen means pulled of the specimen of some certain patient. We have to control as well as we have to preserve it for the internal quality control purpose. Okay, so that we will understand what are the materials is required. If I am sum upping the materials, first thing one is dried freeze materials. Second is pooled serum, and third is the frozen patient specimen. These three kinds of quality control materials we can use as for running a quality control. Don't worry, we will learn how it's happening. Okay. See, now I am coming to just keep in mind this section. If you are not able to understand, just say me. Okay, because we are now going to a very core part of clinical biochemistry, very core part of quality control. If you are not able to understand these kinds of things, you will not able to understand the things what's I gonna discuss with you, so that it is also important to understand. Okay, see, first thing is the pre-analytical error. There have the error. Firstly, our quality control motto is to identify the error and rectify the error. So that the first thing is we need to identify the error. After that, we need to rectify these kinds of error. Now we are understanding in the identifying way. Now we are understanding is the in the methodology where we can identify the error, and after that we will move to the rectification. Okay, and after that we will run the quality control. First we need to understand what kind of error might be happening into our clinical biochemistry laboratory. Okay, see, firstly, pre-analytical error. Keep in mind that one thing, please keep in mind that analysis. What are the things? Analysis. Analysis means doing the test, right? Analysis means doing the diagnosis, doing the test, right? Analysis. From here, the term is come, that is analytic. Analytic. Getting my point? Analysis. For doing the analysis, which kinds of things basically uses, that is for analytic. Getting my point? For doing the analysis, which kinds of particles or which kinds of things are required, that is called analytic. Okay. See, so that analysis is defining that the test happening. So that here is a pre-analytic, analytical, and post-analytical. It defining that pre-analytical means before doing the test or before doing the analysis, which kinds of problem might be occurred. That is pre-analytical. And during running this test, which kinds of error might be happening, that is analytical. After completing the test, which kinds of error might be happening, that is post analytical error. Getting my point? One is pre-analytical, another one is the analytical, and another one is the post analytical. Pre-analytical defining that before test, analytical defining that during test, and post analytical defining that after test. Okay, see, pre-analytical error might be sample collection error. Whenever you are collecting the sample, if you are not collecting the sample in a proper way, then it might be defect, or it might be one type of error. If you are collecting the sugar sample in EDTA file, that is also one type of error. If you are collecting the sample with binding the tunicate for calcium, It is also one type of error. Okay, firstly, sample collection error, because without doing the sample collection we cannot move to the analytical section, right? So the sample collection is required. See, second is the storage error. If you are failing to store the proper specimen or proper serum or proper testing things, then your sample or your specimen will not give you the proper result. So that it is important to store it properly. Okay, after that, the documentation section. Documentation means if you are just doing the labeling, if you are not labeling the properly, if you are just doing the mistake in the label section, if you are mislabel the sample, if you are just writing the another patient's name in the another patient sample, that will be one major error. Okay, that is a documentation error. After that, patient related error. Patient related error means if the patient wanna give the fasting but the patient have already taken the meal, that is one type of error, right? Because fasting does not taking any kinds of meal, as well as fasting does not require any kinds of meal, right? Or if the patient want to give the PP but the patient had completely fasting, that is also one type of error. Getting my point? So that's all are the patient related error. So that these four types of error might be happening into the pre-analytical error. Okay, and rectification, how you will rectify. Here we have understood the error, now we have to rectify it. If the error is happening in the collection, then you have to consult and you have to hire the concerned pathologists like you guys, phlebotomist. Okay, you have to hire the concerned phlebotomist and laboratory staff. Okay, second, if any kinds of verification or labeling error, then you have to cross check it. Third, you have to storing it or the handling protocol you have to enhance. And fourth, clear instruction in the patient regarding sample preparation, means whenever you are collecting the sample, you have to give the instruction to the patient properly, whenever you will take the meal and after how many hours you have to give the blood. Getting my point? So that's all the rectification, that's all the pre-analytical error. Do the test is not happening right now, before doing the test this kinds of analytical or this kinds of analysis might be happen, that is called pre-analytical error. Getting my point? Say me up to this much, any doubt? Tohiba,
No, sir.
Tohiba,
Yes, sir.
good evening, why late?
Yeah, sir. Now I'm coming for the marketing, sir. Now I'm seeing the market, sir.
You are missing the class and doing the marketing, right? Is the
Yeah, yeah,
marketing
sir.
important more than class?
No, no, sir.
No, I'm just joking, kidding with you. Don't worry. Are you fine? Okay. Upendro, where is Upendro?
Yes, sir. Yes, sir.
How are you?
Fine, sir.
Understanding the things?
Yes, sir. Yes, sir.
Okay, fine. Up to this much, anyone have any problem? Up to this much understood?
Yes, sir. Yes, sir.
Okay, thank you. Anyone have any problem up to this much? I faces various type of various new students, so that I'm just asking you all guys, if you are facing any kinds of problem, just ask me. Like here is a Opendro pile, they all are already comfortable with my class. Okay, okay, okay. I think that everyone are understanding. Okay. Now I am coming to the analytical error. Pile, any problem or understanding?
No, sir.
Okay, fine. See, now we are coming to the analytical section. Analytical error means which kinds of error basically happening during the test. Whenever the tests are happening, there should be some kinds of error might be happening, right? That is called analytical error. And into the analytical error, there have also two types. One is systemic and another one is the random. Systemic basically defining that arise or systemic is called consistent error. Systemic error does not occur suddenly. Systemic error is persistent. Systemic error should be present in a consistent way. Okay, whenever any kinds of systematic problem or there should be, or there might be problem into your instrument, there might be problem into your procedure, there might be problem into your standard, there might be you are using the another instrument for doing this kind of test. These kinds of whole error are under systemic. When your system is disrupted, when your system is fault, when your system is not working, system is not only the machines, system is also the procedure, in which procedure you are doing the test, that is also under the system. Getting my point? So that systemic error defining that, see, equipment calibrations issues might be happen, procedural faults might be happen, in a incorrect standard might be happen, and faulty instrumentation also might be happen. Keep in mind that these kinds of thing might be happen in the systemic error. Faulty instrumentation means you have chosen the another instrument. Incorrect standard means you have chosen the another standard. Procedure fault means you have following the another procedure. Getting my point? That's all are under the systemic error. Okay, that's all are under systemic error. If you are doing these kinds of systemic error, you will not able to doing the test, as well as you will not able to getting the result properly. That's all are under systemic error. Getting my point? After that, if I am coming to the rectification section, then what will you do to rectify these kinds of error? What will you do to preventing these kinds of error? See, routine equipment servicing, you have to service the equipment in a routine way. After that, cross validation, alternate alternative method. If you are not getting the proper result into this particular methodology, then you have to choose the another method. After the implantation of the calibration protocol, you have to do. Okay, that's all are the systemic error. If I am sum upping these things, that systemic error define that whenever the system is error or system gives the error, that might be procedural, that might be instrumentation, that might be standard. Okay, see, after the random error, it can easily happen. It is not consistent. It is too much widely occurring error. Okay, that's basically firstly repeating error, because you and I don't know when these kinds of mistake might be done. That is repeating error. And incorrect reconstitute of the reagent means you are choosing, for say for example, for doing the creatinine test, sample is required 500 microliter. If you are not getting the 500 microliter, or if you are getting 200 microliter, that is a error. That these kinds of error is randomly happen, right? And that is not into our hand, right? These kinds of error are randomly happen. And another thing is the instrument error, and last one is the unpredictable. This random error is unpredictable. You and me does not give, we cannot give the guarantee of our hand, we cannot give of our, you cannot giving the guarantee of our repeating, right? Because that is not into our hand. There might be slightly different into our particular result, there might be slightly different into these particular things whenever we are collecting the sample, whenever we are doing the reagent, as well as whenever we are doing the procedure. There might be single times of, or there might be single times of changes, randomized changes, that is under randomized error. Getting my point? So that if I am sum upping these things in pre-analytical error before sample collection, as well as pre-analytical error is before the test, analytical error is during the test. There is two types. One is systematic, another one is a random. Systematic, I have already told you that, and random, I have already told you that. Random under pipeting, under reconstitution of your reagent, under it is very unpredictable in nature. Getting my point? Say me. Up to this much, any problem in analytical section? Up to this much, any problem in
No,
analytical
sir.
section? Okay.
No,
Anyone
sir. No, sir.
facing any problem? Iqbal, how are you? Many days later, I am meeting with you. Is everything
Fine, sir.
fine?
Fine.
Too much
Fine, fine,
fine.
sir.
Okay, 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 okay. No, Shubhodip. Shubhodip, are you understanding?
হ্যালো স্যার,
Gaurhari, say me.
বলছি স্যার আজকে একটু লেটে এসেছি স্যার। আজকে বিষয়টা কি স্যার একটু বুঝতে পারলাম না,
Quality
লেটে
control.
এসেছি আজকে।
Quality control. Quality control. ল্যাবে তো কোয়ালিটি কন্ট্রোল হয়, সেই কোয়ালিটি কন্ট্রোলটা আজকে পড়াচ্ছি, বুঝলে?
হ্যাঁ
আর
স্যার,
পুরোটা বুঝিয়ে দেই, তারপরে যদি তোমার সমস্যা থাকে আই উইল
ঠিক
সলভ ইউর
আছে ঠিক
ডাউট।
আছে
ওকে গৌরহরি?
ঠিক আছে
Okay,
ঠিক আছে
fine,
ঠিক আছে
fine, 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 fine. And say me, are you getting the benefit? Gaur, are you getting the benefit from our platform?
হ্যাঁ স্যার
Okay, okay. Gaur is
হ্যাঁ স্যার
also okay, okay, okay. Thank you, thank you, thank you. So that I have already covered the analytical error as well. Okay, I think that everyone understood. Now we are coming to. I'm saying you one thing that quality control. These kinds of things are very big thing. You might see into your surroundings that quality control. Oh, quality control. How must be the things? No, that is very easy things if you are understanding the things. There is nothing to understandable. Just you need to understand the core part. I'm just coming to the core part, and after completing this class you will not able to getting any kinds of doubt. It's my guarantee. After completing this class you will not able to face any kinds of problem related to quality control, because I will give you the whole theoretical part and you will apply into your laboratory the practical part. Okay, because these kinds of some kinds of things are depend upon the instrument, some kinds of things are depend upon your laboratory, some kinds of things depend upon your senior, some kinds of things depend upon your environment. I cannot give you the full guarantee of these kinds of whole, what can I say, prerequisition as well as whole kinds of factor. I cannot give you the guarantee, but I am giving you that from conceptual guarantee. You will not able to face any kinds of problem. Okay, see, now we are understanding the post analytical error. What is post analytical error? See me, say me. Post analytical error means, so that I have already told you, pre means before test, pre here is the analytical, after that post analytical, right? See, pre analytical means before test, analytical means during test, post analytical means after test. Getting my point? Pre analytical error means which kinds of error are occurring, which kinds of problem are occurring before test. Analytical means during test which kinds of problem might be occurred, and post analytical means after test which kinds of problem might be occurred. Getting my point? That now I am discussing about the post analytical. See, typographical error. Typographical error means after completing the test, whenever you are writing the wrong report into this particular patient, like say for example sugar is 140 milligram per deciliter, but you are mistakenly type 100 mg per dl. That is wrong, right? That is the error that is under post analytical. Okay, after that, misassessment of the result in incorrect patient record means if you are just doing the another one's report to another one's hand, that is also incorrect patient record. Okay, that's might be under the post analytical error. So that what will you do, you can make a automated data entry system. Nowadays there have the automated data entry system into various laboratory. You have to just type it and report pad automatically generated. You have to just print it and give to the patient. Okay, that is called automated data entry system. If you are incorporated this kinds of system, then it can easily helpful to doing your whole procedure. After the regular audit in the reporting protocol, if you are doing the regular audit to your report, then the procedure as well as the error might be prevented. Getting my point? So that we have already covered the pre-analytical, which kinds of error might be happening before test, which kinds of error might be happening into the during test, that is systematic and random, and which kinds of tests are basically, or which kinds of error are basically happening after test, that is called post analytical error. Getting my point? Post analytical error means that is some kinds of typographical method error, some kinds of result incorrect patient error. Getting my point? That's all are under the error. One is pre, another one is analytical, and last one is the post analytical. That's all are types of error. We have to rectify these kinds of error. After that we will run to the quality control. Okay, Semi, up to this much, any doubt?
No, sir.
Okay, anyone facing any doubt? Up to this much we have covered the error section. We have covered the types of error. Anyone facing any doubt? Jinnaton is there?
No, sir.
Jinna, any doubt?
No, sir.
Understood the thing?
Yes.
Okay, fine. Anyone else? Anyone want to say anything? Anyone have any doubt? Anyone? Okay, I think that everyone are understanding. Okay, whenever I am giving you the opportunity to interacting with me, you can interact with me. It's your opportunity. Okay, see, because time is too much short. Within 1 hour, we have to complete lots of things. Time is too much short. So that whenever I am giving the opportunity, just interact. Because our schedule is too much busy schedule. There is too much less in time. So that, see, now we are understanding the types of quality control. One is internal quality control and another one is the external quality control. And after completing these two things, we will go to the core part of today's assessment. That is a core part. Okay, see, now we are understanding the internal quality control. Internal quality control means you are doing the control, you are maintaining the quality into your laboratory internally. Here does not require any kinds of external body. Getting my point? These things is only required into your laboratory. Okay, and within this laboratory, basically it's happening. Okay, see, firstly, accuracy. What are the focuses area? What are the fundamental things basically? One is accuracy. Ensure the test result closely matches to the true or reference result. Into your laboratory, there have a reference result, so that you have to match with this reference result. That is internal quality control first part, as well as that's basically fundamental things. After that, precision, evaluate the reproducibility of your result under in the identical condition. In any kinds of condition, you have to evaluate the result in a fine or good way. That is the precision. After that, sensitivity. Sensitivity means is your result is sensitive. Whenever we are doing any kinds of ELISA, there have two terminology. One is sensitivity, another one is specificity. Sensitivity means your reaction is in proper way. You are getting the reaction properly. You are taking the result properly. That is called sensitivity. Ability to correctly identify the positive cause. Yes, that defines that you have the ability to identify that the reaction is happened. That is called sensitivity. That's all are under internal quality control. Okay, and last one is that specificity. Specificity defines that you have to ability to identify one specific organism, one specific result, one specific reaction, one specific reagent. That is called specificity. Getting my point? So that sensitivity we have understood, specificity we have understood. Sensitivity means is the reaction is occurring or not. Specificity means is this particular things present or not. That is specificity. And if I am defining these terminologies here, ability to correctly identify the negative cases. If you are identify the positive cases, if you are identify the specific things, then the negative things or negative cases automatically identified. That's basically the things. How do you doing these kinds of internal quality control? How do you maintaining the internal quality control? See here, one is the routine monitoring. You have to monitor the whole things, whole phenomena routinely. After that, detection of the error. After that, uses the quality control tools like Levy Jennings chart. I will discuss with you what is Levy Jennings chart. I will discuss with you what is Western Gate method and anything else, which kind of things. I will obviously discuss with you. Don't worry. After that, maintaining the standards protocols. That's what are the internal quality control. Internal quality control does not require any kinds of external body. Keep in mind that internal quality control means which happening into your own laboratory particularly. It does not require any kinds of external body. Okay, you are enhancing your internal status of your laboratory. Okay, say me up to this much any doubt? Up to this much any doubt?
No, sir.
Okay, now we are going to the external quality control. Okay, see here. External quality control. External quality control. External quality control means there should be present from external body. External body will evaluate your lab's result. external body will evaluate the quality of your lab. That is called external quality control. Inter-laboratory comparison compares the test results across with multiple laboratory. Means whenever you are establishing any laboratory, there have also another type of laboratory, so that it basically compare this result and this result, accuracy of this result and this result. That is called inter-laboratory comparison, because there should be one special as well as there should be one specific as well as accurate result. This laboratory and this laboratory, they are doing the competition to getting closer this particular result. Getting my point? So that which result is too much closer to this quality as well as to this particular result, which result is too much, what can I say, too much closely to this particular reference result, or to this particular real result or reality of this particular result. That is the inter laboratory comparison, and that this laboratory is suitable. Secondly, proficiency of testing. See, conducting the external agencies like NABL, like ISO, they all are the external body, right? And if I'm doing about if I'm saying about the college, they have the neck visit, right? Neck. And another one is the another lots of kinds of another types of AICTE, UGC, they all are the team. If I'm, because I am belonging in the college and academic section, so that I am saying you that. And this kind of agencies basically comes into our colleges as well as into our uh, teaching area. They are coming and they will check our quality, we are teaching properly or not, we are taking the viva, we are taking the interviews, we are taking the lessons, we are taking the laboratory, we are taking the classes properly or not. They are checking our quality, that's into our colleges. That's basically the into the college. And but into the laboratory, they are basically external agencies will come and they will give you a blind sample. You will not able to understand which sample is this, you will not able to understand which patient sample is this. They will give you and they will check your quality of result. If you are doing the whole test properly, then you will get the proper result, right? Or if you are hampering any kinds of things, then you will not get proper result. Okay, see, identify the systemic error. If any kinds of systemic error, see, investigate and rectify the difference. If any kinds of systemic error are occurred into this laboratory, if any kinds of system are not running properly, then here we have to identify it, this external quality control. So that I have already covered internal quality control, I have already covered the external quality control. Just say me, anyone have any doubt up to this much? Up to this much, if I'm sum these things, one is internal, another one is external quality control. So that up to this much, whatever we have understood what is quality control, we have understood what are the objective of quality control, we have understood that what are the types of error might be happen, pre-analytical, analytical and post-analytical, right? We have understood how to it's rectified. We have understood that types of quality control, one is internal quality control, another one is the external quality control, we have understood, right? We will right now go to the core part. Before going to the core part, just say me, anyone facing any doubt, anyone have any confusion, any doubt, any questions?
No, sir.
Much?
No doubt.
Yeah. Machina, from where you are belonging, I'm just seeing you first time, so that asking you, because and there have lots of students, I basically know them personally as well as into my another batches, they basically done, so that it's the first time I am seeing you, so that asking you, from which region you are belonging?
Sir, I am from Manipur.
Manipur. Okay, you are a
Yes,
student
sir.
or working?
Working.
Very good. Are you understand in English?
Yeah.
Yeah.
Both Hindi and English.
Both Hindi and English. You're Manipuri.
Yeah.
They have also the another language in Manipuri, right? Manipuri
Yes,
language
sir.
or regional
Manipuri
language,
language.
right? Or
Yeah,
you are a
Manipuri
regional
language
language?
only.
Yeah. I understand. But English is the international language, so that you have to acquire it, right? English and Hindi.
Yeah, sir. Sure.
और काम चलाने के लिए
Yeah.
ठीक है कोई बात नहीं. I have also another student from Manipur. Tahiba is also Manipur. Upendro is also Manipur. I know them very well. They all are the very good as well as attentive student. They all are also belonging from Manipur. Okay, I have got one of the bunch of students from Manipur as well. Okay, thanks a lot for attending as well as thanks a lot for listening. No, the class is not finished. We have to go lots of things. Okay.
Thank you, sir, for teaching us.
No. Thank you for giving me the opportunity to teaching you all, guys. It's my pleasure. Okay, just say me. Anyone have any doubt? Otherwise, I have to move lots of things we have to understand today. Just take some water. If you are boring, if you are just feeling tired, just take some water as well as energy drink. We have to learn lots of things until or unless I can teach, or until or unless these things are complete, I will not able to complete this class. And after this class, I have also taken another classes also. Not you guys, but also another guys also. Okay. Okay. I think that everyone has understood. Now we are coming to very much important section. Okay, you should be stay tuned with me. Just that's all are the very much interactive as well as attractive things we need to understand. Just give me 1 second time. I have to take some water. After that, I will definitely start these things again. Just a second. See, anyone have any idea regarding standard? Anyone have any idea regarding standard? I will just take 30-second time. If anyone wanna say, then say, because time is too much precious. Say me. Anyone wanna say about standard? What is standard? Because I think that everyone are already connected into the laboratory, various laboratory. You are doing their job, right? As well as there have some kinds of students who are doing internship, as well as there have some kinds of students who are doing work in laboratory. There have also DMLT, BMLT students also present. MMLT student also present. Okay. See, so then I am saying you that standard is the thing. There should not be present any kinds of another substance. Getting my point? Into the standard, there should not present any kinds of another substance. Standard should be purified. If I am giving you one example, that standard, if I am giving the example of glucose, into the glucose standard is 99.99%. Getting my point? So that glucose standard we are taking 100, yes or no? 100 we are taking as a standard of glucose, right? So that keep in mind that standard should be, there should be purified substance. Standard is uses for comparison purpose, so that we can compare with the taste, we can compare with the blank, so that we can get the OD, optical density. Getting my point? So that we can easily do the calculation part. And nowadays every machines are automated, so that does not require any kinds of calculation. But I will teach you how to calculate. I will teach you how the reaction is happening. I will teach you where the color development are happening. Okay. See, now we are coming to the control. So that understood standard, there should be always purified of this particular substance. There should not present any kinds of another substance, and it's basically uses for comparison purpose. Okay, control, it is a sample of known value. It is also same like sample, but there have the known value. It is tested in a way of patient sample is tested to ensure the methodology. Getting my point? And this is sample is physically and chemically same to an unknown specimen. Just keep in mind that control is also looking like same. Control means you have to collect the sample and there should be known concentration of the sample, means you have to collect some healthy sample. We have run these kinds of sample as an control. And if I am defining this, as if I am differentiating these kinds of two things, where so that I have mentioned here the table, just keep in mind that these kinds of note is formed by our platform, not like any other body. And now you will see that into your Facebook this kinds of content is completely we are posting, and next day another platform are also taking some things and posted that. It's completely created by our own, not like that's a copy and paste, and not like another platform. And see here, there is every kinds of logo and everything's are already incorporated here. Here is also, that is our logo and watermark as well. And here you can also see, here you can also see these kinds of content require lots of effort, but they are just copying and doing the paste. What can we do? We have no time to doing these kinds of things. See, one is standard, another one is a control. Standard means the material concentrated to calibrate instrument. Getting my point? Means there should be purified concentration, as well as it is help to comparison. and control is the materials with known value to monitor the performance and analytics. So that standard is required for calibrate the instrument and control is required to monitoring the performance and analytical position of this test. Purpose to calibration and establish a reference range, so that without doing the without using the standard, you will not establish the reference range, you will not just getting the normal range as well. And control basically to monitoring the accuracy, is it accurate or not, monitoring the precision, is it occurring within the particular time or not, is reliability, is it dependable or is it believable or not. Control basically monitor these things, and standard basically calibrate the machines. Standard basically to establish a reference range. Okay, example, primary standard certified reference materials, and control basically, see, frozen pooled serum sample, I have already told you that. Lympholytes control, I have already told you that. And standard example like glucose standard 99.99% or 100% standard we are using. Error detection, standard basically detects the systematic error during the calibration. Whatever I have told you, that if you are not getting the idea of error, how can you say that what is systemic error? Systemic error, there might be 4 types, right? Systemic error, that might be instrumentation error, that might be procedure error, that might be region constitutional error. These kinds of error might be happening into the standard, and they basically detect these kinds of error. And control basically detect the random and systemic error in daily testing. It detect only systemic error, and it also detect the random and systemic error of daily testing. Getting my point? Have you got the idea about the standard and control? Control is also look like sample, and standard is the things it is commercially purchased, and here should be only this particular concentration should be present. Purified material, that is standard. Known. Control is also known. Same. Any doubt up to this much? Up to this much? Any doubt? Anyone
No, sir.
saying any doubt up to this much? Okay, fine. Understood control and standard. Okay. Now we are going to understand the Levy-Jennings chart. Okay. Keep in mind that. I am saying you 3 times so that it have a lot importance. Levy-Jennings chart is the mother of clinical biochemistry. Without Levy-Jennings chart, you will not able to getting any result of your laboratory. Getting my point? Levy-Jennings chart is the mother of quality control. Levy-Jennings chart is the core part of clinical biochemistry. Whenever you will face any kinds of viva related to clinical biochemistry, first question should be, have you any idea related to Levy-Jennings chart? If you are not able to say that, they will not give you the job, because it is a very basic idea of clinical biochemistry. And whenever you will go to the laboratory and you will say, we have done lots of batches, we have done lots of study related to clinical biochemistry, but if you are not able to saying about the Levy-Jennings chart, they will think that you are saying the wrong things, or you are not capable to doing the job into your laboratory. You are not capable because you are not remembered the Levy-Jennings chart. Okay, because it's a very fundamental things. Just understand these things. Okay, if you are not able to understand, say me that there have some kinds of math calculation. There have some kinds of sharp. What can I say? Sharp brain is required. Not sir, my brain is also not sharp. I am also too much weak in math. Don't worry. But you will understand these kinds of small math. Okay, so that we are moving the medical field, right? We have not understand the math. So that, see here, but you will understand little bit math here. When many days later I am attending the math classes, math means there will be little bit math. Okay, you will also understand that the interesting things going to be happen. See here, basically Levy-Jennings chart we are going to understand. See here, see. Firstly, we required 10 sample. You can take 20 sample, you can take 100 sample, you can take 200 sample, you can take 1000 sample. It's your own wish. But I have taken here 100 sample. Getting my point? I have taken here 100 sample. One sample value is 93, another sample value is 10. 90, another sample value is 104, another sample value is 102, another sample value is 98, like that. Okay, and I am just getting the means of this sample. Mean of this sample means you have to just sum up the whole things and divide it by the number of sample. Getting my point? You have to just sum up the things. Whatever sample you have to collect it, you have to just sum up the thing. After that, you have to divide it with the number of sample. What are the number of samples, Semi? What are the number of sample here I have taken?
10.
10.
10. Very good. So that partly just focus here properly. Okay, one by one focus here. If you are missing these things, you will not able to understand. So that 10, right? So that firstly I have to sum up the whole value dividing by 10, and we are getting 100.4. We are getting 100.4. So that is our mean. That is our semi mean. Okay, so that our mean is near about 100, right? 100.4, that is near about 100. So that our mean is 100. And how much number of sample we have taken? Semi again. How much number of sample we have taken? 10. So that n is 10. See here, n is 10. Now I am coming to the calculation section. Okay, SD means standard deviation. SD means standard deviation is equal to, see here, root over sum of x minus x bar whole square divided by n minus 1. Okay, and x minus x bar whole square defining that x1 minus x bar whole square plus x2 minus x bar whole square plus dot 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 means after that x3 minus x bar whole square, after that x4 minus x bar whole square, right there. Okay, so that if I am doing the calculation here, there should be the calculation like that. So that the first x1, Semi, what will be the x1? What will be the x1?
100.
100.
X means 100, sir.
100 is the x1.
Yeah.
Minus, there should be 100. Yes or no? Because x bar is 100
Yes.
into whole square plus, if I am saying I am just giving two example. After that you can easily calculate. So that next x2, what will be the x2 pile? X2
Oh, 105.
105 minus semi minus 100, right? Minus
100.
100 whole square plus x3 10 minus 100, like that. Are you understanding how it's happening? Okay, see, are you understanding how it's happening? After that, divided by n
Yes,
minus 1.
sir.
What is the value of n? What is the value of n? Semi, what is the value of n?
10.
10, right? N is the number of sample 10 minus 1. So that the SD is 6.4. That is the calculation. And from this given sample, the SD is calculation. So keep in mind that if you are taking the another result, your SD should be different. That is example. Okay. So that what is the standard deviation? Semi, what is the standard deviation? 6 point, Semi,
6.4.
6.4. Okay, 6.4. Say now here I am taking three things. One is, see here, one is x bar plus minus standard deviation of 1. See, x bar, if I am using the terminology, just focus here. If you are not able to understand, say me. Okay, just focus here. Like x bar plus minus 1 SD. 1 SD. See, Semi, what is the x bar? X bar, what is x bar? Here, 100, right?
100.
100. So that 100, if I am taking the plus first, plus 1. 1 means 1 into SD. SD, what is the SD? 6.4, right? 6.4. So that we are getting 106.4. Yes or no? 106.4. That is the first. Second, if I am taking x bar minus 1 SD, 1 SD, and there should be 100 minus 6.4. Yes or no? 100 minus 6.4 means 1 into 6.4, that is 6.4. So that you are getting the result semi, the getting the result 104.6, right? Yes or no? 104.6. So that the result should be like that. Okay, that is the plus, that is the minus. Okay, okay. So that if I am taking 1 into SD, then 6.4. If I am taking 2 into SD, 2 means 6.4 into 2, so that 12.98. If I am taking 3 into SD, 6.4. Getting my point? 3 into SD into 3, 18.12. Like that. Understood? These things up to this much understood?
Yes, sir.
Okay. Now we are calculating the chart. Up to this much, everyone understood the calculation? If you are not able to understand, say me. If you are not able to understand,
Yes,
say me.
sir.
Okay, okay. Up to this much clear? Up to this much clear?
Yes, sir.
So that I am now doing to the chart. Okay. Now we are going to the graph. How it's happening? See, see the graph. See. Okay. Now here is the day. Is the first day, second day, third day, fourth day, fifth day, sixth day, seventh day, eighth day. Getting my point? Here should be the day. Okay. In this day, how we are getting? And it is x bar, right? It's x bar. X bar is equal to how much? X bar is equal to 100. Yes or no? X bar plus minus. Just see here. If we are getting the result in first day 100, if I am taking one sample, if I am taking the one sample, that is x1. Understanding the things? X1. See, x1 100, right? If I am taking the x2, means next day, day after day, one particular sample. Here is the example of one sample. One particular sample, day 1 100, day 2 97, day 3 103, day 4 107, day 5 115. Okay, that is the result of this particular sample. After that, see, that is the graph. X bar is equal to how much? Same, x bar is equal to 100. X bar plus
100.
1 SD is equal to 106. Here I am getting, yes or no? X bar plus 1 SD is equal to 106. See here. Understanding?
Yes, sir.
X bar is equal to 106. X bar plus 1 SD is equal to 106. So that here you can see, that is 106. Yes or no? 106. X bar plus 2 SD, that is 112. X bar plus 3 SD, 118. Yes or no? And here is x bar minus 1 SD, that is 94. X bar minus 2 SD, that is 88. X bar minus 3 SD, that is 82. Are you understanding the calculation how is happening? X bar. Getting my point or not? Understood?
Yes, sir.
Okay, see. Now I am doing the graphical representation. So the first day that was 100, and second day, see, first day that is the 100, within the 100, right? And second day, see, within second day, I am just present here. Second day within, see, it is a 94. Second day within 94. Yes or no? Second day within 94. Third day, see, third day within 107, that is 103. See, 100 and 106. So that if the result is 103, so that here is put it. Are you understanding the graph? Are you
Yes,
understanding the
sir.
graph? Okay. And the fourth day, semi pile. Fourth day, what is the result? 107. Yes or no? Fourth day 107. So that
Yes.
107 is under 106 and 112. Yes. So the graph is here. Okay. So that the put it sign is here. Fifth day, that is 115. So that 112 and 118, within this there should be present 115. Yes or no? 115. See, that is the result.
Yes.
That is the result. And sixth day, that is also 104. So that 104 is under 100 and 106. So that the signal is put it here. Yes. And seventh day, that is 92. 92 is under 88 and 94. See here. So that here is a put it. Getting my point? And eighth day, that is if you are extending, ninth day and 10th day, you can extend, but my limit is up to this much. See, and then 8 there, that is 105, sorry, 125, that is more than 118. Yes or no? That is more than 118. So that it is
Yes,
more
sir.
than 118. Firstly, we have to put it the dot here. After that, we have to see, draw these lines. Are you getting whatever I am saying? That is nothing. That is the result, and you have put it this chart. That is called Levy-Jennings chart. That is called Levy-Jennings chart. If you I am saying here, that is the X bar is mean is 100 and SD is 6. Getting my point? SD means standard deviation. Are you understood? Levy-Jennings chart. If you are not able to understood, you will not able to understand the next part as well of this class. Already 1 hour is happened. As well, 1 hour is crossed. It takes also 15 minutes. Don't worry. Just stay tuned with me. I will complete the quality control today. Understood? Understood?
Yes, sir. Yes, sir.
Okay. Okay. Levy-Jennings chart. Any doubt regarding Levy-Jennings chart? Any doubt regarding Levy-Jennings chart? So that firstly you have to calculate like that. Okay. That is the Levy-Jennings chart. Okay. Okay. Now the interpretation is C. Values within plus minus 2 standard deviation is acceptable. Getting my point? Within plus minus 2, so that we are taking this value within plus minus plus and minus, within this value is acceptable, means see, within this value is acceptable, so that 8-day value is rejected. Yes or no? 8-day value is already crossed. Yes, 125 it is crossed, it is not acceptable. See, values beyond plus SD is warning signal. Okay, and requiring the closer inspection. Values beyond 3 plus minus 3 is indicated the significant error. So that whenever it cross plus or minus 2 SD, it is the signal that one error is happening. Whenever it cross plus and minus 3 SD is defined that one significant and major error is occurred, so that your value are not matching with your standard deviation. Getting my point? That is the interpretation of Levy-Jennings chart. And now we are understanding these rules. Say me, up to this much understood? Up to this much understood?
Yes, sir.
Okay. Now I am coming as well as I am explaining the too much important topic in this methodology, and if you are understanding these things, you will not face any kinds of doubt regarding the quality control. Okay, that is Westgard rule. Have you listened this term, Westgard rules? In Pallab Basu books, that is mentioned the Westgard rule, right? Not only Pallab Basu, every book basically mentioned the Westgard rule, because Levy-Jennings charts application is defining by Westgard rules. Okay, see, Westgard multi rules. See, one SD, one control is measured exit to deviation to control limits either above of this mean the rule warning, the rule to trigger the careful inspection. Means, see, if it cross, I'm just erasing this part so that I can easily explain with you guys. I'm just erasing, okay, these things. I'm erasing this thing so that I can easily explain the things. See, please memorize this Westgard rule. I will not able to say it again. Please memorize this Westgard rule. Okay, I am giving my 200% effort to clearing your concept as well as to easing these things, because into your surroundings there have a fear to clinical biochemistry. Just advise them to attend my class. They will, everyone can easily release their fear in clinical biochemistry. It's my guarantee. See, firstly 1 SD, 1 to S, that is the first rule. 1 to S. See, if it exceeds the 2 standard deviation in control above or below, it defining that the warning rule, so that we can accept this, but it's a warning. Getting my point? First rule, if it cross plus 2 or minus 2, that is the warning rule. So that first rule is covered. Understood? If the graph is crossed 2S plus and 2S minus, that is the warning rules. Okay, understood? But that is acceptable. This result is acceptable. See, second, 1,3s. The rules commonly used in Levy-Jennings chart when the control limit are set as the 3 mean standard deviation on of a control limit. A run rejected when the signal control measured the level of 3 means control limit. 1,3s. 1,3s. Getting my point? See. See. 1,3s. Just a second. 1,3s defining that when any levels, either that can be positive 3s or that can be negative 3s. If it cross any level of 1,3s means 1 means one single time. That might be positive, that might be negative. Okay. If it cross, we cannot take the result. It is rejected. Understood? So that second rule we have understood. Understood? Machina? Understood?
Yes, sir.
File understood?
Yes, sir.
Okay. So that 1,3s means if one line is crossed, either that can be positive side, either that can be negative side. We cannot take the result. Okay, that is rejected result. Second. Third, 2 2s. If the control run is rejected, two constitutive control measurement, two standard deviation control limit on the same side of this rule. Understood? See. If I am taking repeated two result that might be in positive side of 2s or that might be in the negative side of 2s. Getting my point? If I am getting two repeated results, so that we are saying 2 and 2s means 2 standard deviation. If I am getting two repeated result in either side, that might be positive, that might be negative side, we cannot take the result. That is rejected. Okay, that is the third rules. Understood? Everyone? Understood?
Yes, sir.
So that we have covered the third rules also, right? 2 2s, like see, 4 the rules reject the run if two control measures in a group exceed the mean with 4 standard deviation difference between two control. See, 4 it defines that it exceeds the level of, see, 4 means there is no 4 standard deviation. 4 means I am saying you that 4 means if see, if repeated, if say for example, if 2 repeated that it exit positive side of 2s. If 2 repeated that, we are getting the positive side of 2 2s exit, and if 2 repeated that negative side of 2 2s it exit, that is called R4s. Understood? Understood? That is called R4s. That is also rejected. Understood?
Yes, sir. Yes, sir.
Okay. Okay. Is it too much hard? Is it hard?
No, no, sir.
No. Okay. The thing is hard, but if you are understanding it, it become easy. Okay. The rule rejected. And here is a 4 1s rejected while the 4 constituent control executing one standard deviation on the same side of the mean. Getting my point? See, if that is 1, that is 1. Yes or no? That is 1. See, that is 1. If repeatedly it exit 4 days, 1 1 1 1. If repeatedly exit 4 days, that is called 4 1s. That is called 4 1s. That is also rejected. Understand? And 10x, the rules reject the control when its 10 constitutive value on the same side of a mean. Any kinds of mean, whenever you will give, whenever you are getting it exit 1s or it exit 2s or it exit 3 days, and in a repeated way in 10 days. 1 2 3 4 5 10 6 7 8 9 10. If it exit repeatedly 10 days, it's also called the rejected. We cannot take the result. That is called 10x. That's all are the whisker truth. Is it too much tough? No, it's too much easy. Are you understanding? So that we can only take one result, that is 1 1 1 2s, right? That is only 1 2s. Otherwise, whole result we have to reject. Getting my point? So that your function should be, you have to run the sample. After that you have to make this Levy-Jennings chart. After that you have to match with this Westgard rules. And nowadays does not require these kinds of things. Machine will give you the Levy-Jennings chart. Yes or no? Machine will give you the Levy-Jennings chart and just match with this Westgard rule. Say me up to this much, any doubt? I am already ending stage of this lecture.
No, sir.
Anyone facing any doubt? So that if I am saying that whatever we have understood, what is quality control? What are the types of error? What are the objective of the quality control? What are the rectifications of this error? As well as what is the fundamental things of standard and control? What is the difference between the standard and control? What is Levy-Jennings chart? How the data is put into the Levy-Jennings chart? What is Westgard rules? How the occurring of this Levy-Jennings chart is occurred? And what are the multi-rules of the Westgard rule? How it's matching? We have understood the whole things, as well as we have understood the internal quality control and external quality control. Anyone have any doubt? Anyone facing any doubt?
No, sir.
Anyone facing anyone?
No,
Say me. Anyone else? Anyone else? Anyone wanna say anything? It's the first time you are attending my class, so that I'm talking with you. Many of you are first time. Mashina, are you understanding really the whole things? Whatever I have told?
Yes, sir.
Okay. Very much fine. Okay. So that I am requesting all of you, if your surroundings, because that is the first class, if your surroundings, anyone wanna join into our classes, just refer them so that they can also take the benefit. Okay, it's my humble request to all of you, so that they can also take benefit of these kinds of classes. It's my humble request. Please spread into your surroundings if anyone wanna join these classes. And these kinds of missed class, they will they will take the recorded version as well. Okay, and they will get everything. They will not, you guys also. Okay, and it's my humble request as a spread if anyone wanna join these classes. Okay, and thanks a lot for joining.